Determine the area of each polygon. Remember, for a rectangle, we use base times height, and then our units are going to be squared. For a triangle, we use base times height, and we divide it by 2 or multiply by 1/2. So we'll do 6 times 9 is 54, and then 54 divided by 2 is 27 inches squared. You'll also need to determine the area of these polygons. This is a parallelogram, which is found in the same manner as a rectangle. Base times height. In this diagram, we don't have any 90-degree angles to use for the base and the height. So we can try an alternative strategy where we create a 90-degree angle coming off of each side. So we would have a base and a height built in. And then same thing here. We could create a base and a height to form another triangle. And one more here as well, with a base and a height. Now, in order to find the area of this shape in the middle, we could find the area of the whole rectangle and then remove the triangles from the sides. Keep in mind, removing the area of those triangles is the operation subtraction. So to start, we're going to find the total area of the entire rectangle. So the rectangle has a base of 1, 2, 3, 4, 5, 6, 7, 8, and a height of 1, 2, 3, 4, 5, 6. Then we're going to work on the area of triangle Q, which the base is 8, the height is 2. And for triangles, remember, we divide it by 2 because it's half of a rectangle. For triangle R, the area would be a base of 3 and a height of 1, 2, 3, 4. Divided by 2. 3 times 4 is 12. 12 divided by 2 is 6. This one P has a base of 5 and a height of 1, 2, 3, 4, 5, 6. Five times 6 is 30. 30 divided by 2 is 15. So to find the area of the triangle piece in the middle, we're going to take the rectangle's area and remove the area of Q, the area of R, and the area of P. So all that's left is the area of triangle S. 48 minus 8 is 40. 40 minus 6 is 34. 34 minus 15 is 19. Units squared. Plot the points A at 0, 0, B at 1, 4, C at 2, 2, and draw triangle ABC. Find the area of triangle ABC. So again, we're going to make a rectangle around the outside of the shape. We have 3 triangles to remove from the rectangle. So we'll start with the area of the rectangle, which is a 2 by 4. So that piece is the rectangle, and we will remove this first triangle, which is a 1 by 4. Then this triangle here, which is a 1 by 2. And the triangle on the bottom, which is a 2 by 2. Remember, for triangles, it's base times height divided by 2. 2 times 4 is 8. 1 times 4 is 4. Divided by 2 is 2. 1 times 2 is 2. Divided by 2 is 1. 2 times 2 is 4. 4 divided by 2 is 2. 8 minus 2 is 6. Minus 1 is 5. Minus 2 is 3. Plot the points D at 0, -3, E at 2, -2, and draw ADE. This one has a straight side here, which is 3 units. If we draw in the height, this has 3 as the base and 2 as the height. But it's a triangle, so it's base times height divided by 2. 3 times 2 is 6. 6 divided by 2 is 3. Area gets units squared. Then part C says to plot F, this one's still at A, F at -6, 0, and G at -7, 1. Find the area of this triangle. This has a base of 6 and a height of 1. Triangles are found by base times height divided by 2. 6 times 1 is 6. 6 divided by 2 is 3. Write and evaluate 2 numerical expressions to find the area of the trapezoid. Well, one method is to cut the trapezoid into a rectangle with 2 triangles. This rectangle has 1, 2, 3, 4, 5 as its base, and its height is 1, 2, 3, 4, 5, 6. This triangle has a base of 2 and a height of 6, and this triangle over here has a base of 3 and a height of 6. In this problem, we're going to combine the areas. So I'll start over here with this pink triangle. To find the area of that, I have 3 times 6 divided by 2. Then we'll find the area of the rectangle piece and add it to the triangle piece. This one has a base of 5 and a height of 6. Remember, the rectangle does not have to get divided by 2. Then we need to find the area of this green triangle and add it in as well. This green triangle has a base of 2 and a height of 6, but triangles get divided by 2. It says write and evaluate, which means find the answer. 3 times 6 is 18. 18 divided by 2 is 9. 5 times 6 is 30. 2 times 6 is 12. 12 divided by 2 is 6. 9 plus 30 is 39. 39 plus 6 is 45 units squared. Another method for composing or decomposing the trapezoid is to form 2 triangles. This triangle has a base of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a height of 1, 2, 3, 4, 5, 6. So that is 10 times 6, and triangles get divided by 2. This triangle up here has a base of 1, 2, 3, 4, 5, and a height of 1, 2, 3, 4, 5, 6. So this is base of 5, height of 6, divided by 2. 10 times 6 is 60, and 60 divided by 2 is 30. 5 times 6 is 30. 30 divided by 2 is 15. And 30 plus 15 is 45. Again, that's units squared. So either way that you decompose these trapezoids, you still arrive at the same area of 45 units squared. Show one way to decompose the polygon. Then use your decomposition to write and evaluate the numerical expression to find the area of the polygon. We can cut it into a triangle here and here, and then the rectangle piece is in the center. So I have a triangle, and a rectangle. Let's start with our rectangle piece. The area of our rectangle piece, the base of that rectangle, if we count the units, is 12, and the height is 4. 12 times 4 is 48. The area of the green triangle piece, it has a base of 4 and a height of 4. But don't forget, triangles get divided into 2 parts because it's half of a rectangle. 4 times 4 is 16. 16 divided by 2 is 8. For the blue triangle, we have a base of 4 and a height of 4 as well. So that also has an area of 8. To find the total area of all of these pieces combined together, we have 48 plus 8 plus 8, giving us an area of 64 units squared. Plot the points A, B, C, D, E, and F in the coordinate plane, and then draw the polygon and find its area by using two different methods. Here on our X and Y axis, you can see that it's counting by quarters, quarter, 2 quarters, 3 quarters, a whole. So 1.75 is 1 3/4. 1 3/4. This would be where A is located. B is 2 3/4 and 1 3/4 up. C is 3 3/4 and 2 quarters or a half up. D is 2 3/4 and down 3/4. E is 1 3/4 and down 3/4. F is 3/4 and 2 quarters. Then connect them to create the polygon. A, B, C, D, E, F. You can graph these same coordinates on this grid. And we need to find the area using two methods. I'm going to start by cutting this one into a rectangle with two triangles. With this green triangle, it has a base of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a height of 4. Ten times 4 divided by 2. The blue rectangle has a base of 4 and a height of 10. Remember, rectangles do not get split into two parts. Then this pink triangle also has a base of 10 and a height of 4. Four times 10 is 40. 40 divided by 2 is 20. 4 times 10 is 40. 10 times 4 is 40, and 40 divided by 2 is 20. So the total area, 20 plus 40 plus 20, makes 80. Okay, but wait. They're not actually 10 tall. We gotta fix this. They're counting by quarters on our axes, remember? We have, instead of 10 tall, we have 3/4, a whole, 2 wholes, 2 1/2. By 1. This is 2 1/2 tall. And 1 wide, because 4 boxes make a whole. And then the triangle piece here is 2.5 by 1, and it gets divided by 2. All right, 2.5 times 1 is 2.5. 2.5 divided by 2 is 1.25. 2.5 times 1 is 2.5. 2.5 times 1 is 2.5. Divided by 2 is 1.25. Now, if we add all those together, we get 5 units squared. Another strategy you might try is cutting this shape into multiple triangles. All right, let's start with this pink triangle. It has a base of 4, but 4 of them turns into one hole, and a height of 0.25, 0.5, 0.75, 1, 1.25, and it's a triangle. The orange, this is 4 boxes makes a hole, 1, 2, 3 holes, and the height is 1.25. The green is 3 holes as its base, and it has a height of 1.25. And then the blue has a base of 1 hole and a height of 1.25. If we break up all those pieces into how much area they have, 1 times 1.25 divided by 2 is 0.625 for the pink part. Then the orange part, 3 times 1.25 divided by 2 is 1.875. The green part is also 1.875. And then the blue part is also 0.625. When we add all those together, we should end up with the same area as before because it's the same shape, but it's just decomposed in a different format. Which expression can be used to determine the area of the polygon in square units? Choose all that apply. Well, if we break it up into a rectangle and a triangle, this rectangle is 8 units by 4 units, and the triangle is 8 by 4, but it's split in half. So here I see the bottom rectangle and the top triangle added together. We wouldn't want to subtract them because we want the total area here. We could also cut this up into another triangle. Here's an 8 by 4 triangle, an 8 by 4 triangle, and an 8 by 4 triangle. That would be 3 8 by 4 triangles. That is E. 8 times 4 divided by 2 would be 1 triangle, but we need 3 of them. We could cut this into 2 triangles. that are 4 by 4s. I see 4 times 4 divided by 2, and 2 sets. That would be this piece here, 2 sets of a 4 by 4 triangle. And then if we cut these into 2 4 by 4 squares, that would be this piece here. So F also works. If we made the outside a big rectangle, this would be 8 wide and 8 tall. So that's an 8 by 8 square. I see those both here. But then I would need to remove this triangle here and this triangle here. These are 4 by 4 triangles. So 4 times 4 cut in half or divided by 2. I see that here, and there are 2 of them. But removing would be the subtraction, so we want C, not D. So A, C, E, and F can all be used to find the area of this shape. Consider points A, which is at 3, 2, and B, which is at -3, -2, plotted in the coordinate plane. Suppose A and B are 2 vertices of a rectangle with an area of 24 square units. What are the ordered pair of the other 2 vertices of the rectangle? Use the coordinate plane to draw the rectangle and check the area. If these are the vertices of a rectangle, we can extend out past A and extend out from B and see where they cross. And then do the same in the other direction and see where they cross. So I've created this rectangle here in the center. It has a height of 4 and a base of 1, 2, 3, 4, 5, 6. The question said it had an area of 24. For a rectangle, we do the base times the height to find its area. Is 6 times 4 24? Yes, it is. So the question was, what are the ordered pair of the other 2 vertices? Well, the other 2 vertices are these points where those parts cross. So we need to write the coordinates or the ordered pair for these points. This point up here is at -3, +2. And this point over here is at +3, -2. Suppose points A and B are 2 vertices of a parallelogram that is not a rectangle and has an area of 12 square units. What are the possible ordered pair of the other 2 vertices of the parallelogram? Use the coordinate plane to draw the parallelogram and check the area. Well, the area for a parallelogram is found by using the base times the height. If I was trying to get from B to A, that would have a height of 4. We were told in the problem that our area was 12 square units. Right now, B is being multiplied by 4. So to solve it for B, I would divide both sides of my equation by 4. 12 divided by 4 is 3. B times 4 divided by 4 is B, which means my base needs to be 3 wide. So I'm going to put a point here at the ordered pair 0, -2. and I'm going to connect to this piece, and I'm creating another one that has a 3 across, which is the point 0, positive 2. Then a 3 as a base and a 4 tall gives me an area of 12. Suppose A and B are two vertices of a triangle with an area of 6 square units. In the triangle, it's base times height divided by 2. We were told here that the area is 6. I can see here that if I was going to go how tall is it, this would be in height of 4. Well, 4 divided by 2 is 2, so this is 6 equals the base times 2, because this piece is equal to 2. To undo multiplying by 2, I divide by 2 on both sides of the equation. That leaves me with B, and 6 divided by 2 is 3. So I need a base that is 3 wide. That puts my coordinates at the point 0, -2. Then I need to draw a triangle coming from those coordinates. That's the end of lesson 6. More on solving area on the coordinate plane.